Welcome to another episode of Let Me Explain My Code. Okay, we're going to start with our get user stats here. One of the biggest things with databases is being able to get your statistics. People love statistics and numbers. It makes making money easier. So we start off with our pagination. That's going to come into play in a little bit. We define our variables that we are going to be using and passing out of our try catch block. As you can see here with our include, we are basically doing a eager loading, which is just a query inside a query, if you ask me. But we are getting the tasks for the user, taking 5. We're sorting them by is complete false and grabbing their ID. We are also getting a count of, I guess, the total tasks. Um, and we have our pagination skip limit, and we are ordering them created at date descending. We then map over this array of objects, array of objects, and turn it to something a little more digestible. We also get our total users from count here, and then our catch with our Prisma error handling information, and hey, our pagination. Checking if, oh, this was something I found out that was really nifty. If there are no users at all, it will not throw any kind of error because the query did what it was supposed to. It went and searched. There was none there. So we check and make sure that there are users. Oh, there's the shape of our object. Don't you love TypeScript? All right. Um, so we throw that to the front end to let them know that nothing came back. Um, then we return our response with okay, users and pagination for what is it? Not sorting, but being able to go back and forth through information. Oh, limiting, this is the point I wanted to get to it. We are limiting the control, we are controlling the flow of data by limiting the amount of data getting returned. Maybe they don't want all 100 of their tasks. They only want to see the first 10, and we limited it to 5 apiece for them. Maybe each query takes, 5. I believe that's it. Yeah, 5. So for their next set, when the query runs, our pagination tells the query, hey, we're on this next set. Skip this, give us this, so on and so forth. And it allows for smaller transference of data, so that's your computational overhead cut down a little bit. All right, let's move on. Search tasks. What a quinkadink. As you can see, we started pagination. We check our query to see if there's anything there or it's less than 2. We don't want anything less than 2. As you can see of the note here, never put the user or client's input directly into the query. We are template literal. After we trim it, we could have did some kind of validation. A little surprised we didn't, but so we trim it, we take that query, and we're running it through a raw query. Now, I want to point this out because this is a good raw query for the use of a user, because you can't get what's the injection? SQL injections. There we go. This, well, it helps prevent SQL injections. So we template literal, and then we put it in, and this is a search pattern, searches the whole thing, the whole query. This is an exact match, and this is our starts with match in case, it's like 3 or 4 letters to the starts with, and they want that whole row, whole column of rows. So I'm gonna assume we did this as a raw query because it is a complex query. It is complex with some joins, and we're going through some like stuff here. Um, then we're ordering it. So we are not only doing a complex join, but we are rating the returns from the search based on exact match, start with, and search pattern. Um, what else? Okay, yeah. So this is also really nice because we don't load this person's whole database of rows from the table of tasks, right? We don't just pull in the whole rows, the whole table of tasks to our database and then filter through it there. No, we have a database that can do it. And though we had to write it in raw because it had, the join and some complex ordering and assigning situations, we allow our database to do a lot of that computational overhead that could cause our server to bog down if we had 1,000 users doing it, where we can look at it and weigh that overhead. Do we want that on our database? Because our database might not be getting as this complex query as often compared to the mapping we're going to do on our server. Oh, no mapping? Which one was the mapping? That one, the other one. I'm sorry, I mixed it up. But all right. So that returns our search pattern. And again, I'm gonna go back to that topic though of putting the computational overhead on the database over putting it on your server. Uh, we returned somewhat of a complex object in this query, so we had to map through it and kind of make it neater for, I'm going to assume, our front end to digest. Uh, let's see, what else after that? You guys wanted me to go into transactions and data consistency. We've discussed that several times before. You want me to show the registration and talk about why the transaction here is necessarily important. um, One of the ideas I could figure with is we want all users as a UI to have these things to kind of remind them, hey, check these out, do this stuff. Uh, it not necessarily more. I don't think it was more for the consistency of the data, more of the consistency for the interaction with the user. But hey, who am I to judge? So we have this transaction run. We have it run because we want all of this to happen at once. We don't want this to happen to a regular user. So that's why we have it in our register. And then two, we want this person to register, create these tasks, to receive them and find them on their page. They're already fetched for them. Our find many. Then we do this with it. We return these fields. We don't want them to have their password. Then we return the user and their welcome tasks. We have these uh, Prisma client known error and code. That guy there. And we could probably go over that in a minute. I wouldn't mind bragging for a second. As well as we went over that. What happens if a rollback happens? The information doesn't get put into the database. The account doesn't get created. The tasks are, well, let's start it backwards. The tasks aren't retrieved. They aren't made for the user, and the user isn't registered on the table. So he is not then a user. And as I look at this, don't judge me. Um, all right. I've had a problem with silent errors lately, and I just want to leave that note for myself. I'm sorry I did that all live for you guys. Um, let's see, what else? Walk through the bulk create menu. I actually liked this. Uh it was programmatic. Oh, and it's programmatic thinking at its best, so we can validate all of our tests. And that's what I liked about it because I never thought about validating the list of tasks for a bulk task. I it never occurred to me. I don't whoops. So we actually loop through it with a for of loop because it is an array we have pulled back from our request body. The test still passed. Anyways, first we check to see if a user is logged in. Then we check the task if it was empty, make sure it's an array, or yeah. So there's it's empty too. A little redundant. So we then loop through this, checking for any validation errors on any of the bulk tasks. Upon passing, we take that value and then we assign it its proper space in the array as a validated task in the shape it needs to be. We then do a create mini analytics controllers. One of the things I may have skipped over are our methods for Prisma that work with our aggregate functions like our count, which I had the perfect opportunity to mention earlier. Uh, but we have many methods within Prisma as far as count, group by, uh, find many, create, find, all these things, right? And we can use aggregate functions with some of them specifically to do things like get our statistic analysis when we do things. As we see, we have these issued pages running here, but that's not giving us things like our total completed or our total non-completed, which are things we can do with it at this point. We just haven't written for that quite yet. Where I thought I had statistics in here, user statistics. See, that was task, get user analytics. Is this one? Yeah, this is one where we actually go over the analytics of their weekly progress and what they've set. And we use a lot of our how we use the group by with the count here, we're actually getting a number returned so that we can do things like run statistic analysis on the amount of tasks we may have done in the last week or so, right? So that's really some of the things I probably could have went over earlier while being in here, but we're going to skip that and just know that, hey, it's here now. All right, so our create mini um, which is one of the things we want to be aware of is that Prisma does offer a lot of things, just like the include. The include to me is essentially a query inside a query, a subquery, if you will. But we are told that Prisma doesn't do some of those things. And it's just, being clever enough to know how to use the tools you have at hand to get what you want, and then understanding, hey, I want my database to do this computation compared to I want to do it on my server, and understanding how these overheads kind of affect our clients and users and balancing that out because consistency and being able to predict things, I think, is a whole just like comfortability in itself, especially in this field, being able to guess or troubleshoot because this is over here. Those things are very beneficial. And I think that is the majority of my presentation and understanding these advanced topics with Prisma. Thank you, and I hope you have a good day.